Hi everyone. So in this lesson, we are going to look at how to create bullet objects in Pygame. Now, if you're not up to date, we're now in lesson 3, and you'll find lesson 3 in my GitHub. There's a branch there. So if you haven't been following along, that's an easy way to catch up. Simply download it and then start working from it. Just to revise what we did last lesson, we've been looking at the use of the Pygame object sprites. A sprite is a visible object. So you'll see here that we created a spaceship object from the sprite class, essentially, or inherits from the sprite class. And we're able to move it left and right and process input. So to look at the code that underpins that, you'll see that we created our own class called spaceship. I have inherited the code from pygame.sprite into that spaceship. I initialized its X and Y position, and I've also initialized the underlying sprite. So this little line here, super bracket underscore init underscore is actually us calling the init function from the sprite class, and that is really important. We also gave the sprite an image. The sprite must have some type of drawing to be able to be seen on the screen. We gave it direction, we gave it speed. Importantly, it must have a rectangle. So every sprite must have a rectangle so it can calculate its position on the screen. We spoke a bit about the use of these things called 2D vectors, which is simply an X and a Y position. You'll see that in our sprite, we've got a draw function and we've got an update function. The update function is processing our inputs. Currently, I've just got a couple of inputs, being the keys A and D. And what we're going to do is we're going to use the spaceship to create lasers. So we will be creating lasers from the spaceship. One of the things I'm not sure I covered in the last lesson was just to check that the sprite is inside the actual screen. So to do that, I've actually got a function called game_is_sprite outside of rectangle, and I created this function myself. You'll see it inside game globals, and basically says if it's outside the rectangle, I don't want it to have any speed, but if it's inside the rectangle, it has a speed of 4. So that's going to make it so that our spaceship can't basically go off screen, and that's good for the time being. Okay, let's look at how we can create a bullet object, or a laser, as I've called it. So you'll see that there is a file called laser.py, and inside this file, we're again going to import in Pygame. We're going to import in my globals file. Remember, I'm saving things globally under the alias of game. And I'm going to create a class called laser. And just like we did in the previous tutorial, that class called laser is going to inherit code from the Pygame sprite object. We're then going to give it an init function. Now at this point, we can decide what type of variables we want to pass in to this object. And from my way of thinking, I think it'd be a good idea to have its position, its direction, and its speed. That way, when we create the laser, we could actually pass in a different speed if we wanted to. We can pass in a different direction. And if you think about it, the position that we want to pass in will be the position of our spaceship. So that's where I want to create my laser object. Just like last time, I need to call the init function of my sprite that I'm inheriting from. So whenever you see super bracket init, it basically says initialize what was below it. I'm going to give it an image. Now in this case here, I don't have an image to load up. I mean, I could have given it an image, I suppose, but there's actually a really easy way to create a rectangle image in Pygame, and that's simply to create a surface. So I'm going to create a surface with a width of 3 and a length of 15. And it's just like a rectangle. And I'm going to fill that surface with a color. So knowing that we're using RGB, I've decided to fill it in with green. Then we need a rectangle, just like before in the spaceship. We can initialize a rectangle from the image itself, and I'm going to pass that rectangle my center position. So my X and Y coordinates are going to come from position, and that's going to initialize my rectangle. And then I'm going to also initialize the position itself. I want to give my object a direction. I'm going to give it the speed. Again, these are just coming in from the inputs. So the three inputs are being passed into position, direction, and speed. A bit different. I'm going to give it a sound. I want to give it a sound effect. Now I have got a laser MP3 file saved in the sounds folder. So I'm going to play that. And you can see how easy it is to play sound in Pygame. And then, now, this is where life gets a bit interesting. So currently we've got a laser, but I want you to think about this. You could actually have lots and lots of lasers on the screen at one time. And so sometimes you'll want to check all those lasers. For instance, give you an example. If I wanted to see how many enemies my lasers have collided with, I need a way of searching through all the lasers. So Pygame has a really nifty way to do that, and it's called a sprite group. And a sprite group is essentially a list of objects. We're going to define that sprite group in main, and you'll see I've put it inside my globals. So if you go right to the top of the page, we're going to add in this thing called and I've just called it bullet group, mainly because there could be lots of different objects that you put inside your bullet group. With my bullet group, I create it, and that's the variable name. The variable name is bullet group, and I've saved it globally inside the game namespace. But essentially it's a group, which is just like a list. So it's actually a list of objects. So you can imagine if we had a list of objects, you would have a laser 1, laser 2, laser 3, and you can imagine if there's hundreds of lasers on the screen at the same time, then you're going to have hundreds of lasers in your group. The good thing about using a group instead of just, say, a list, and I could have used a list, is that a sprite group in Pygame does all the collisions for me. So it actually will save me a lot of code doing it this way. Despite the fact it might be harder for you to understand because you would be more familiar with the idea of lists, a sprite group is a list for all intents and purposes, but it allows us to do collision. So I create myself that bullet group, and when I create the laser, I'm going to add it to that bullet group. So you can see game.bulletGroup add. And because I've imported in game globals, it means that all my global variables are available to me, and I'll be able to add it to that group. So that's in my bullet group now. And then what I want to do is create the laser. So to create the laser, I'm going to go to my spaceship. And in my spaceship object, I'm going to go to where the keyboard inputs were. And you can see I've got if pressed Pygame key A. I'm going to do if pressed Pygame key space. And I'm going to say, well, if that's equal to 1, then the space bar has been pressed. And just for the moment, I'm just going to create the laser. I'm not going to worry about talking about timers inside the spaceship yet, but we will get there. So you can see I've got L is equal to laser. I pass it in my own position because I want to create the laser at the position of my spaceship. I'm going to pass it in the direction, and the direction I want is for it to fire upwards. So I'm going to create myself a 2D vector, and the 2D vector has 0 horizontal and -1 vertical. And then I'm going to give it a speed of 10. So you can see that those inputs there correspond to the inputs inside my laser. So I'm going to pass it position, direction, and speed. I'm passing my laser the position, the direction, and the speed. Now it doesn't know what laser is yet because I need to import in my laser file. So right at the top of my spaceship code, I need to say from laser, import laser, and that will bring in the laser code. So now my spaceship is creating this laser object, and I could have called L. I mean, I've just called it L, but it doesn't actually matter because every time I create this object, remember, it actually gets created and added to the actual bullet group. So inside main, this bullet group is going to be populated with lasers. The final thing I need to do is, with a sprite group, I need to be able to draw the sprites. And there's a really simple way to do that. In Pygame, when you have a sprite group, all you need to do is just say the name of the sprite group, which is game.bulletGroup, draw, and then you pass in the screen. And that line there means that it's going to draw every single sprite that has been added to my bullet group. And I know what you're thinking. You're thinking, well, how can that happen if laser doesn't have a draw function? Well, this laser doesn't have a draw function. You can see there's no draw function here. But the reason it's still able to draw is because it inherits from Pygame.sprite. This sprite object does have a draw function. And so all I'm going to do is I'm going to call the draw function of Pygame.sprite, and it's going to draw every single one of those sprites from within my bullet group. And all I need to do is pass it what surface I want to draw onto, which is my screen. Note that I'm drawing my bullets before I draw the player, which means that the player will be drawn over top of the bullets because it's the last thing to draw. Okay, let's see where we're up to. So I'm going to press play here, see if I've made any mistakes, hopefully not. Now you can see that I'm creating lasers, but the lasers aren't moving. And also if I hold down my space bar, you can see that it's just going to create lasers every single frame. So that's the next step. But you can see that it is creating bullet objects at the moment. So we need to make it so that those bullets are able to move forward. So if I go back to my spaceship where I create the laser, you can see that I am giving my laser the direction I want it to travel in, but it's not updating my laser's position, which means that I do need to have an update function inside my laser. So I'm going to go to my laser, I'm going to go and I'm going to give it an update function. And in my update function, I'm simply going to add the direction vector times the speed. So you can imagine if direction vector is simply going 1 up, the speed will make it so it's going 4 up or 10 up at a time. I see, I think I've got speed at 10. So it's going to add 10 times that one direction to my position. So the position's y value is going to actually be timesing by 10. So it's going to go, this here is actually going to be negative. So it's -1 is the direction, times by 10 is -10. So my position vector is going to be updated by -10 every frame. The other thing I need to do is once I update the position, I need to realign the rectangle. Always need to realign the rectangle. If you don't realign the rectangle, then it won't draw properly. Right, so that's got it so it's now moving. What I do need to do though is make it so it doesn't shoot lasers like a laser beam. And it's actually a bit of fun to have a look at. So let's just have a look at how it shoots lasers like a laser beam at the moment, and then we'll talk about how to fix the problem. Actually, I don't think I've saved. So let's just make sure I've saved that, because oh no, I have forgotten to call the update function. So even though my laser's got an update function, I do need to call it. So let's go to main, and in my main loop, so in my game loop, I need to update all the sprites inside my bullet group. So let's go to where it's got updating. And here I've got update the sprites. I need to update every sprite inside my bullet group. So I say game.bulletgroup.update. And again, because we're using a sprite group, it'll call every single function inside my laser. So I'm going to press play now. Hopefully this will work. Going on. There you go. So now if I hold down the space bar, you can see that I have now got hundreds of lasers being created. So it's working and it's not working. Let's fix that, because I don't think the player should have the ability to do machine gun fire. So I'm going to go to my spaceship, and the way to fix that is to basically create a timer inside my spaceship. So I'm going to create the timer, I need to know what the last shoot time was. So initially I'm just going to say self.lastShootTime is equal to 0. That's just going to basically create a variable that I can store when was the last shoot time. And then I can say, okay, well, if time.time subtract the last shoot time is greater than 0.5, as in a half a second has gone past, then, and only then, am I going to create my laser. Just be careful to get your indents correct here. Only then will I create my laser, but then I need to keep a record of that last shoot time. So if 0.5 seconds has elapsed between the current time and the last shoot time, create the laser, save the last shoot time as the current time, and then it'll keep working like that. So for all intents and purposes, I have created a timer inside my spaceship that will stop it from being able to shoot all the time. And now, let's see how it goes. Actually, just one more thing I wanted to point out. We also want to make sure that the lasers don't exist after they have exited the screen. And this is important because if every object contains variables and we're creating hundreds of those objects, we're creating hundreds times the number of variables inside those objects. So every time you create a variable, you're actually using up memory. So we are using a whole bunch of memory up. If the computer runs out of memory, obviously it's going to lock up. So we need a way of deleting the lasers if they exit the screen. And there's quite a simple way to do that. There's actually a collide rect method. I mean, I could have actually used the same method as in my spaceship if I wanted to, but this is a neater way to do it, where I basically say if this self.rectangle does not collide with the rectangle of the screen, that is, it's off the screen, then I call self.kill. And self.kill is a function that resides inside every sprite. So it's something that we've inherited inside the sprite class, is a function called self.kill, and it basically destroys the sprite. And it will actually also remove it from the sprite group, which is really cool, because the sprite group should always keep a track of what sprites are there. So self.kill will destroy the sprite, also remove it from the sprite group. Okay, let's see how we're going. There we go, and I can no longer do machine gun fire. Perfect. Right. Okay, and that concludes our tutorial. Thank you very much for listening.